Hello friends, I welcome you in lecture number 26 on relations. In this lecture also we are going to discuss one example on graph of a relation. Using the graph of a relation, we can decide or observe certain properties of given relation. So here the question is determine whether the relations for the diagrams shown below are reflexive, symmetric, antisymmetric or transitive. So we have discussed this type of example in lecture number 25 relations also. So if you have not seen that lecture, I suggest you to watch that lecture first and then go for this lecture. So here this is the graph and we have to first decide whether it is reflexive or not. Now we know that our relation is reflexive if there is a loop at every vertex of the graph, and here we can see there are three nodes or vertices and there is a loop at each vertex of this diagram. Therefore this relation is reflexive. Now for symmetric property, we require that if there is an edge between two vertices, then there must be a written edge or written arc between those two vertices. Here we can observe that there is an edge from vertex A to vertex B, but there is no reverse edge between these two vertices. So there is an edge from A to B, but there is no edge from B to A. Therefore this relation is not symmetric. For antisymmetry, we require that there must not be any written arc or written edge between two vertices. So here we can see between B and C there are two edges, or there are edges in both the directions. If relation is antisymmetric, then there must be an edge between two vertices which is having only one direction, or there must not be any written arc between two vertices. So here, because there are two edges, or there are edges in both the directions for vertices B and C, therefore this relation is not antisymmetric. And last we have to check whether it is transitive or not. So for transitive we have to check all the possibilities. Here we can see there is an edge from A to B, that is A is related to B, and there is an edge from B to C, that is B is related to C. There is an edge from A to B, that means A is related to B. There is an edge from B to C, that is B is related to C. And if relation is transitive, we must have A related to C. But we can see here there is no edge from A to C. There is an edge from C to A, but there is no edge from A to C. That means A is not related to C. Therefore this relation is not transitive. So you should write all these things systematically whenever you have this type of example. Here I have written that there are loops at every vertex of the diagram. Therefore R is reflexive. We can see all the vertices are having loops. And as I discussed, relation is not symmetric because there is an edge from A to B but not an edge from B to A. And relation is not antisymmetric because for vertices B and C there are edges in both directions. And for transitive property we have to write that there is an edge from A to B and an edge from B to C, but no edge from A to C. This means A is related to B and B is related to C, but A is not related to C. Therefore this relation is not transitive. So from the graph also we can directly observe some properties of given relation. We have not written the relation of this relation representing this diagram. From the diagram itself we are able to decide whether the relation whose diagram is this is having certain properties or not. I have taken another diagram also. Here also I have to decide whether it is reflexive, symmetric, antisymmetric or transitive. So for reflexive property we must have loop at every vertex, and here we can see there is no loop at vertex A. Similarly, there is no loop at vertex C. So this relation is not reflexive because every vertex is not having a loop. For symmetry, we require that whenever there is an edge between two vertices, then there must be a written edge between those two vertices. So here we can observe that there are edges in both the directions for all the vertices. For A and B, there is an edge from A to B, there is an edge from B to A also. Similarly, there is an edge from A to C as well as from C to A, for A to D as well as D to A. So there are edges in both the directions, therefore this relation is symmetric. And it is not antisymmetric because for antisymmetry we require that there must not be an edge in both the directions, and here we are observing the edges in both the directions, therefore this is not antisymmetric. For transitive we have to check different possibilities. Here we can see there is an edge from A to C, that means A is related to C, and there is an edge from C to A also, that means C is related to A. And if relation is transitive, then we must have A related to A, that is there must be a loop at vertex A, but there is no loop at vertex A, that means A is not related to itself. A is related to C and C is related to A, and if relation is transitive we must have A related to A, but here A is not related to itself because there is no loop at A, therefore this relation is not transitive. And we have to write all these things systematically. I have written that relation is not reflexive since loops are not present at all vertices of the diagram. We have seen that for vertices A and C, loops are not present. R is symmetric because for every edge there is a written edge, and R is not symmetric because there are edges in both directions. And R is not transitive because there is an edge from A to C, that means A is related to C, and an edge from C to A, that is C related to A, but no edge from A to A, that is A is not related to itself, therefore R is not transitive. So these are the simple exercises in which we can decide that whether relation is satisfying some properties, and that we are deciding from the directed graph of the relation. So this is all about this session. I hope you like it. Thanks.